Silicon carbide kiln roller, a hollow ceramic tube that rotates inside a roller hearth kiln, carrying loaded saggers from one end of the furnace to the other through temperatures above 1000 degrees Celsius. Every roller in the kiln bears the full weight of the material passing over it, under continuous heat, for months without replacement. What you see here are silicon carbide roller tubes are engineered to match a specific kiln width, load profile, and temperature zone. What keeps a ceramic roller running under load inside a furnace for months without bowing or cracking? Start with stiffness. An elastic modulus above 300 gigapascals suppresses mid-span deflection, even when the roller supports 80 to 150 kilograms of loaded saggers across a multi-meter span. Then thermal conductivity. At 120 watts per meter Kelvin, silicon carbide transfers heat through the roller wall fast enough to minimize temperature gradients that would otherwise build thermal stress. A coefficient of thermal expansion around 4 times 10 to the minus 6 per Kelvin, roughly half that of alumina, means the roller grows less as the kiln heats up, reducing the risk of binding against the kiln sidewall bearings. Service temperature up to 1380 degrees Celsius for reaction-bonded silicon carbide, covering the full calcination range of lithium cathode materials. And flexural strength between 250 and 350 megapascals, verified on every roller before it ships, because a roller that fails under load inside a running kiln stops the entire production line. 2 silicon carbide grades serve the roller kiln market. Reaction-bonded silicon carbide covers temperatures up to approximately 1380 degrees Celsius, which spans the full calcination range for lithium cathode active materials. It offers the best cost-performance balance for high-volume battery material production. Sintered silicon carbide extends the ceiling to 1600 degrees Celsius for processes that demand higher thermal headroom, such as technical ceramics firing or DPF sintering. Both grades are available in multiple outer diameters and wall thicknesses to match the kiln width and the load weight in each firing zone. Before shipping, ADCERAX laser tests every roller for straightness. The specification holds deviation to 0.8 per thousand of the roller length or tighter. Inside a roller hearth kiln at a lithium cathode active material plant, hundreds of silicon carbide rollers form the conveyor that moves loaded saggers through the calcination zone, 700 to 1200 degrees Celsius, 10 to 30 hours of continuous firing, air or oxygen atmosphere. Every sagger sits directly on the rollers, and the rollers rotate slowly, advancing the entire batch from entry to exit without interruption. If the calcination temperature is not uniform across the kiln cross-section, the cathode crystal structure varies from sagger to sagger, and battery performance becomes inconsistent from cell to cell. Silicon carbide rollers, with thermal conductivity at 120 watts per meter Kelvin, distribute heat through the roller body fast enough to reduce cross-section temperature gradients, a measurable advantage over alumina rollers that conduct heat at roughly 1/5 that rate. If a roller creeps, bends slowly under the static weight of the saggers at high temperature, the saggers tilt, powder redistributes unevenly, and the calcination quality of that batch is compromised. The elastic modulus above 300 gigapascals and the low coefficient of thermal expansion of silicon carbide resist that creep, keeping saggers level across the full span. And the operational reality that every kiln manager understands: a single roller failure inside a running kiln halts the entire line. Every sagger behind the brake cannot advance. Downtime in a gigawatt-hour scale cathode plant costs tens of thousands of dollars per hour. Silicon carbide rollers deliver 8 to 10 times the service life of alumina rollers in the same position, and that lifespan multiplier is the reason every major CAM producer building new roller hearth kiln lines specifies silicon carbide.